Hello everyone, welcome to my channel. Today we will discuss about deadlocks. This is the agenda of today's session. First, we will understand what is deadlock and the causes of deadlock in SQL Server. Then we will learn how to detect and resolve deadlock issues. Let's get started. As you might know, SQL Server has multiple layers of objects. We have database, inside of database file. Inside database files there is a table and each table consists of extents. Inside each extent we have 8 data pages. Each data page consists of several 8 kilobyte sized rows. Okay. Inside each row also there can be index keys and row identifiers, which we call RID. When you connect SQL Server, a session is created. If you run query inside the session, transaction is created and this transaction acquires log on one of the objects before running. This is to keep integrity and consistency of the data. Logs might be acquired at one of these levels. It might be at row ID, key level, row level, page level, extent level, okay, even at database level. The type of query you are running and type of indexes you have defines where logs should be taken. If SQL Server takes high-level logs like database, table, or extent-level logs, we call this process as log escalation. After acquiring the log, workers thread is allocated and this transaction is run on this thread. There are a few types of logs: shared log, update log, exclusive log, and intent logs. This is a table of log compatibility in SQL Server. As you can see, some logs like exclusive log is not compatible with other log. This causes log contention in SQL Server, which we call blocking. For example, in session A, transaction acquired exclusive log on this page because it is running update statement. While this transaction is running, another session started with select statement and tries to acquire shared log on the same page since it needs the data in this page also. However, as shared and exclusive logs are incompatible, session B cannot acquire log until session A releases exclusive log. In this case, session B is not allocated a worker thread, but is put in wait status with LCKMS wait status. This kind of waits often occur, to tell the truth, and last in microseconds in SQL Server. Therefore, it is expected behavior usually. But if this wait lasts about 5 seconds, 10 seconds, even minutes, we call this as log contention because our queries become very slow. In other words, we call this kind of issue as blocking. So now what is deadlock? We understand blocking, right? So what is deadlock now? Deadlock happens when two transactions block each other by holding logs on each other's resource. For example, two sessions are running at the same time. One is with shared log and the other one is with exclusive log on different pages. Suppose at certain stage transaction B needs to acquire log also on the same page, logged by session A. However, since there is already a log there, it is blocked and put in wait status. At the same time, session A also needs to acquire log on the page logged by session B. However, it cannot since there is already incompatible logs there. So these transactions cannot complete as they are waiting each other. This issue is called deadlock. To resolve this issue, SQL Server automatically detects this deadlock issue and chooses one of the sessions as victim and kills it. SQL Server terminates the current batch being executed for the thread, rolls back transactions of the deadlock victim and returns 1205 error. Okay. Rolling back the transaction for the deadlock victim releases all logs held by that transaction. This allows transactions of other threads to become unblocked and continue. Okay? In other words, one is killed, another one is continued. So, how a victim is chosen? SQL Server chooses as a deadlock victim the session running the transaction that is least expensive to roll back. Alternatively, you can specify the priority of sessions in deadlock situation using set deadlock priority, of course. Deadlock priority can be set to low, normal, or high. In this case, low priority session is killed. Okay? Now we understood what is deadlock and how it is handled by SQL Server. Let's now discuss about the causes of deadlocks. The first one is log escalation. For example, suppose you have following table and you are running update statement for all the rows where color is red in session 1. If you do not have index in this case, SQL Server does table scan operation and checks each row one by one and find target rows and updates them. Of course, until this session finishes, these rows stay locked with exclusive lock. Suppose our table is huge and it is taking time for session 1 to finish update statement. During this time, session 2 started select statement and against the rows with color blue. In this case, as we don't have index for color column, what SQL Server does is again go through each row, check it and bring it to the user. However, as our second row is already locked, our select query is quickly blocked at this stage and this blocking can lead to deadlock. What's the solution here? Solution is creating an index against color column. If you create an index, SQL Server does not need to check whole table, but directly go to the target row. In this way, blocking and deadlocks do not happen. Now, another cause, lack of worker threads. Depending on your system configuration, there are limits of the number of worker threads. For example, if you have 16 logical CPUs, by default SQL Server allocates 352 worker threads. Large amount of connections and parallel processing in SQL Server can consume large amount of worker threads. As a result, deficiency of worker threads might happen. This lack of worker threads can also cause worker-related deadlocks. How? Let's see. Suppose session A started and acquired lock on page 1. It gets worker threads and starts running. At the same time, session B starts and acquires lock on the page. However, at that time there was not worker thread available and as a result, this session has been put in wait with source worker status. After several milliseconds, session A requests lock on page locked by session B and blocked. As a result, deadlock arises. In order to release the lock, session A should give worker thread to session B, which never happens, right? This can also be called as deadlock on worker threads, worker thread deadlock. Okay, so from this we can see that deadlock does not only happen on database, pages or something. Deadlock might also happen on worker threads, which is also resource. Of course, if a worker thread becomes available within deadlock timeout period, which is usually about within 5 seconds, this deadlock is released automatically. But what if the worker thread does not become available? In this case, SQL Server kills one of the processes as deadlock victim. Okay, to resolve this kind of deadlocks, firstly, try to find why so many threads are being used in your server. Secondly, you can also increase the number of threads available and add more CPU for more threads. If your query has sorting and joining row activities, SQL Server requires temporary execution memory to run this query. And in this case also, deadlock might happen. For example, due to some memory contention in the server, SQL Server has only 100 MB available for execution memory. During this time, two concurrent session B and session A started, suppose, and they required 60 MB each to run this query. But as there was not enough memory, each got only 50 MB. Additional 10 MB is needed for each. Due to this, they are put in wait status, and if memory does not become available within deadlock timeout, one of them is killed as deadlock victim. We can call this as execution memory deadlock. Okay, sessions compete for execution memory and deadlock with each other. To resolve this kind of issues, you should look at why memory contention is happening and, if necessary, allocate more memory. If you are interested in learning execution memory more deeply, I highly recommend watching my another session on this topic after this session. Parallel executions in SQL Server can sometimes also cause deadlocks, depending on what kind of query you are running and query execution plan generated by SQL Server. Suppose session A started with query, where parallel execution is possible. As a result, parallel threads are started and they took logs on rows correspondingly. During this execution, suppose threads try to access each other's locked rows, and deadlock arises as a result. This is often observed behavior in SQL Server. Often, decreasing maximum degree of parallelism is solution here. Now, we are much clearer about what is deadlock and how it happens in what cases, right? Let's now troubleshoot deadlock issues and see in real life points which we discussed until now. First, I create bottleneck or blocking issue by running update statement against product table and do not commit. Then, In another session, I run select statement against the same table, product table. As you can see, I face bottleneck here. My query is being blocked. Because the first session took exclusive lock on the table level, this session is trying incompatible shared locks. This blocking is happening. We can check this bottleneck by using these three queries. To filter the result, I'm specifying the session IDs of these two conflicted sessions. Our first session ID is 67 and second one is 51. 51 is being blocked here. Let's have a look. You can find wait status here with session ID 51. It is not being completed. This session is waiting for key resource to be released and being blocked. This is wait status and blocking session ID, which is our first session, right? Let's check the same resource. As you can see, this resource has been locked with exclusive lock by our first update session, 67. So this is the example of blocking, okay, which we already talked, right, until now. Let's now switch to deadlock issue. Firstly, we start this transaction where we are changing the city name. Here I'm not committing transaction, so the exclusive lock is not released. Next, I go to another session and run another update query against another product table, different table. Now, we have exclusive locks in both address and product tables, okay? Let's run this select query against product table. As you can see, we are blocked in this case as there's already exclusive lock there by another session. To generate deadlock, I go to another session and run select query from there also. Then, as you can see, we face deadlock issue. Suppose you don't know what is happening and face this kind of deadlock related error, for example, in production environment or development environment. Okay, what steps do you follow? Firstly, in any case, you should go to health check log, where deadlock related logs are recorded. As you can see, until now we faced 4 deadlocks. Let's check the latest one which just happened. You click on it and firstly check deadlock diagram. What does this diagram mean? As you can see, I had 2 processes, 61 and 63. Session 63 has been selected as victim. How deadlock happened? Session 63 is requesting shared lock on key. However, this key was being locked with exclusive lock by session 61. It is owner session, okay? At the same time, session 61 is requesting shared lock on another key, but it is owned by exclusive lock by session 63. As a result, SQL Server took this case as deadlock. Very straightforward diagram, right? Now we understand how deadlock happened, which sessions are being blocked, and how which session was selected as victim. Let's switch to why deadlock happened and how to resolve now. As I told you, there are mainly 4 causes of deadlock, right? Parallel execution related deadlock, lack of execution memory related deadlock, lack of worker thread deadlock, and lock escalation deadlock. Which case we are facing now? Let's check. First, for educating purposes, I will start with execution related deadlock case. Here, we are not facing this problem. Why? As you can see, process ID of deadlocked threads are different. If process ID would be the same, we would think the deadlock is happening because of parallel threading. Let me show you an example of that case. This is the example. As you can see, Deadlock is happening within only one process with process ID 60. If you want to check more, you can see details. This is a parallel workers thread ID. First is victim thread. Process is here 60. As you can see here, with victim thread, overall 9 worker threads were working and we faced deadlock here. In this case, as already discussed, you should consider decreasing max stop. In our case, we are not facing the same issue, right? Therefore, we rule out parallel processing related case here. Okay, we are not facing this issue. Next, switch to another case, lack of execution memory. To check whether our query requested any execution memory and it acquired requested memory, simply run these queries. This query gives you detailed information on memory grant. As you can see until now, only one query requested memory, and requested memory was granted without any issue. If there would be any memory grant issue, there would be less granted memory here than requested memory. Okay, very simple to check. This issue does not exist here. Also, this is not our query, as you can see. So, we can conclude that our query did not ask any execution memory because it did not require. Therefore, execution memory related deadlock is not related to our case. To double confirm any memory contention issue, I usually also check memory consumption in health check logs. Let me show you. I go back to health check logs, open diagnostic logs and sort by state. Go to resource component. As you can see, state is constantly clean and resource main physical is always high, which means that there was not any memory contention issue in our server. You should of course go to the same timestamp, okay? So let's check another case, worker thread deadlock related issue, right? To check whether we had enough worker threads at that time, I again go to diagnostic logs and check this time query processing component. Okay, please pay attention. Query processing component. You can see here my max workers available are 512. And from this, I'm using only 72 constantly. So we can go to deadlock timing and check. You can see that at around that timing also I had enough workers, the same trend. So we rule out this cause also. There is no any worker related problem. Let's go back to our queries. Then we check execution plan of all the queries. As you can see, our update query is doing index scan. It means that it is going through all the table and updating target rows. Let's check our next query. As you can see, our second query is also doing the same, index scan. Now, I will switch to select query. Since it is blocked, I will check live execution plan. Oh, now it became clear. Our select query is also doing index scan. It means it should go through all the rows in the table. It is being stuck as a row where exclusive lock is already taken by update query. So let's check this session. As you can see, we are stuck while checking this key. If we check this key, we will find out that this key is already taken with exclusive lock by update query. Do you remember how to resolve this? Of course, create index, right? Let's do it. I will quickly create an index and reproduce the issue. As you can see, this time our query is not being blocked because we are using index this time to go directly to the target row instead of checking each row one by one. Okay? In this way, we are resolving blocking and consequently possible deadlocks. So this is all points I wanted to talk about today. Thank you for your time. If you like this video, please do not forget to like, share this video and subscribe for more interesting videos. Thank you.